Hello, it's me, Dr. Thamu Hassan. I'm here with the Medical World Series. Today, I'm going to present ECG Machine Calibration. This is basically ECG Machine. ECG is set up to record at the standard 25 mm per second and 10 mm per milliwatt. Now, what this 25 mm per second and 10 mm per milliwatt is, I'm going to tell that in a minute. This is ECG paper. This is a graded paper on which ECG waveform is formed, which is formed against the voltage on the y-axis and time on the x-axis. Voltage is presented by milliwatt and time is presented by the seconds. We also have this calibration signal box. If we look back to the ECG, we are having a rectangular piece of this structure called calibration signal box. This calibration marker should measure 10 mm in height, which is equal to the two large boxes, and 5 mm in width, which is equal to one large box. Now, let's calculate the standard 10 mm per MV, which is basically used in the standard ECG machines, which is plotted on the y-axis. Here we have a large box. Each large box has further 5 small boxes on both x and y axis. 1, 2, 3, 4, 5 on both x and y axis. Each small box is equal to 1 mm, and each small box is also equal to 0.1 milliwatt. Now, one large square will be equal to 1 mm into 5, that will be equal to 5 mm, and 0.1 milliwatt into 5, that will be equal to 0.5 milliwatt. That can be also seen in the figure below. Similarly, two large boxes will be equal to, we have to multiply one large box with 2, so we will get the result. Like in the 5 mm, which was equal to one large box, we have to multiply that by 2, so in return we will get 10 mm. And in the milliwatt, that one large box was equal to 0.5 milliwatt, we have to multiply that by 2, so in the result we will get 1 milliwatt. You can see that in the figure below. So a standard calibration box on the y-axis is equal to two large boxes, and it will be equal to 10 mm per milliwatt, or in simple word 10 mm per 1 milliwatt. Now let's calculate the standard 25 mm per second, which is plotted on the x-axis. Again, each large box is further divided into the 5 small boxes, 1, 2, 3, 4, 5 on both x and y axis. Each small box, one small box is equal to 1 mm, and each one small square box is equal to 0.04 second. Again, when we will calculate the one large square, we have to multiply both 1 mm and 0.04 second with 5, and the result we will get 5 mm and 0.2 second. What does this mean? This means that one large square is equal to 5 mm or 0.2 seconds. Similarly, 5 large squares will be equal to 5 mm into 5, that will be equal to 25 mm, and that 0.2 second into 5, that will be equal to 1 second. So on x-axis, ECG machine will move a distance of 25 mm in just 1 second, that is 25 mm per second, which is the desired calibration we made earlier. So to conclude, if you have set the ECG machine at 25 mm per second and 10 mm per milliwatt, then the height of the calibration marker should be two large boxes, and the width of the calibration marker should be one large box. Thank you. That's all from the calibration of the ECG machine. For more videos, stay in touch.